we're going to look at how to solve systems by using the elimination method. And by eliminating, we're talking about eliminating either x or eliminating y. And again, the goal is to find a coordinate pair. You're going to have an answer for x and y. And the big thing to notice is that in the box, they talk about when solutions will stay solutions. So if you use a property of equality, so if I was to take one of the equations and add it, subtract it, or multiply, as long as I do it on both sides, it should still be a solution. And also they can be solutions if you add or subtract the equations themselves. So we're going to look at two different ways to solve this system. A says that we're going to eliminate x. Now the goal is to eliminate is to have a pair of opposites. So I'm going to take this bottom equation and I'm going to multiply it by 2. So I'm going to multiply every number. I'm going to distribute it 2. So I end up with 4x plus 5y equals 12. And then I have negative 4x plus 2y equals 16. So I multiplied all three of the bottom terms by 2. And then I can, in this case, combine all my like terms. I end up with 7y equals 28. Divide by 7. And then my y is going to be 4. Now, I didn't figure out the whole thing yet. I have to figure out the x value. So I'm going to do that by taking one of the equations. I'll take the top one. And I'm going to plug in, let me erase that. I'm going to plug in the y value, 4, in for y. So I got 4x plus 5 times 4 equals 12. So I can multiply the 5 and the 4 together. And then I have a two-step equation. So if I subtract 20 on both sides, I get 4x equals negative 8. And then divide by 4. I'm going to get that x is negative 2. So that means my coordinate is going to be negative 2, 4. And again, you could plug that coordinate into either equation. It should be true. Now, if I want to eliminate y, like in B, well, I have a 5y, so I'm going to need a negative 5y in the bottom. So I see a positive 1. So I'm going to need to multiply this bottom equation by negative 5. So I'm going to rewrite the top one, and then I'm going to multiply everything by negative 5. So I have 10x minus 5y equals negative 40. Now I end up with 14x on the left column equals negative 28. And again, if you're typing this in the calculator, this is going to be 12 minus 40. Divide by 14. And then x is negative 2. Now I got to go ahead and plug in the x value into either one. I'm going to pick the top one again. So I got 4 times negative 2 plus 5y equals 12. So I can multiply the 4 and the negative 2 together to get negative 8. And then I can add the 8 to both sides. And I end up with 5y equals 20. And again, you can pause this at any point if you need to, if I'm writing too fast for you. Then divide by 5. And then y is going to equal 4. So for each one of these, we get the same two values, negative 2 and 4. So really, there is more than one way to solve any system. Now, we're going to look at another question. We're going to look at exercise 3. Similar to this, they talk about a line that passes through these 2 points. We got negative 2, negative 11, and 314. They want us to find the equation of this line in y equals mx plus b form. Now here's the thing. We have x and y in the coordinate form. So what we're going to do is we're going to rewrite the equation, but we're going to write it in the form with x and y in. So we got negative 11 equals m and then x will have a negative 2 plus b. And then the bottom equation will be 14 equals m times 3 plus b. So the goal is to solve for m and b. So what I'm going to have to do to figure out what m is, I know I have a b and a b. I can multiply one of these equations by negative 1. I'll multiply the bottom one by that. So I'm going to rewrite it slightly using the commutative property. So I got negative 11 equals negative 2m plus b. And the bottom one I got negative 14 equals negative 3m minus b. So I can figure out now what m is going to end up being. I'll have negative 5m equals negative 25, and then I can divide by negative 5. And that'll give me a value for m, which would be 5. So my slope of this line is 5. Now again, if I wanted to find the slope, I could just as easily have done rate of change. This just gives us a different way of looking at it. And in the case of to find b, well, what I can do is I can take that m value, plug it into one of the equations. So I got 5 times negative 2 plus b. So I'll have negative 11 equals negative 10 plus b, and I can add 10 to both sides. So b ends up equaling negative 1. So that means my values for m and b are 5 and negative 1, which means my equation will be y equals 5x minus 1. And I could easily check that in the calculator to make sure that these 2 points are on that line. So this gives us a couple different ways to look at a system. Exercise 3 is something we wouldn't necessarily use as much, but exercise 1 just gives you 2 different ways of solving using algebraic properties.